In this video, we are going to solve the solution, or we are going to discuss the solution of your comprehensive quiz that I've given you yesterday. So for you to practice for your upcoming final exam this week. Okay? So problem number 1 tayo. If bar AB has an angular velocity of 6 radians per second, determine the velocity of the slider block C at the instant shown. So meron tayong slider block at C. So, yung AB natin is rotating at a constant angular velocity of 6 radians per second. Then we need to determine the value of our sandali class we need to determine the velocity of our slider block. So, how to solve that? Using instantaneous center. Pwede natin to solve using relative motion analysis or also using instantaneous center. For me, I would love to use the instantaneous center, no? So, yung slider block C natin will be moving in this direction. Yan yung hinahanap natin, VC. And then, yung velocity ng ating point B will be in this direction. Okay. Velocity ng B natin. So, from there, makakreate tayo ng parang instantaneous center. So, for example, atin nang i-move saglit class Okay, ito dito. So, gawa tayo ng projection line. Ayan. And also this one. So, such that is also perpendicular to our velocity direction. So, this part right here is our instantaneous centers or instantaneous center of both the point B and VC. So, they will be sharing the same angular velocity, no? Omega BC. Okay? Omega BC. Similar lang yun. Okay? So, gagawin natin ngayon is to solve for itong itong side na to. So, this is RB IC. Ito naman yung RCIC. So, how to solve for these values? Okay, una, this one right here, itong part na to, class, itong part na to, is equivalent to 500. No? So, if this is angle 30, so lahat ng ito is 90. So, therefore, this part right here is 60 degree. Now, we can now use the since we have created here we've created here a parang right triangle, no? So, gawa tayo ng right triangle ulit, no? Okay, pwede naman ito actually. Ito, wherein this one is our 90 degree. Now, this will become our hypotenuse. So, given yung adjacent side ng ating angle, which is 60, no? Which is 500 yung adjacent side, 500 mm. So, makukuha natin yung etong part na to, hypotenuse. So, we can just use since meron tayong adjacent tapos hypotenuse yung kinukuha natin, pwede natin gamitin yung cosine, no? So, therefore, itong RCIC hypotenuse natin will be equivalent to 500 over cosine of 60 degrees. And then, itong RBIC natin, since that is opposite, no? So, tangent 60 opposite over adjacent, so that will become 500. Okay, 500 as our adjacent side to be multiplied by tangent of 60 degrees. So, this is our RBIC, this is our RCIC. Okay? So, yung angular velocity ng B, angular velocity ng ng ating member AB is 6 radians per second. From there, we can solve the velocity of B. So, that is angular velocity ng member AB, then that is to be multiplied by the position ni B with respect to A. So, already given na yan, no? Velocity of B, yung angular velocity ng AB is 6 radians per second times itong angle na to, itong length na to, which is equivalent to 200 mm. So, makukuha nating value dito is naka mm. 6 times 200, and that would give us 1,200 mm per second. So, that is our velocity at B. So, gagamitin natin itong velocity at B to solve for the velocity to the angular velocity BC. So, velocity at B is equivalent to angular BC, no? Tapos, RBIC. So, yan yung gagamitin natin. Wherein yung velocity ng B, nakuha na natin to be 1,200 mm per second. Yung angular velocity BC, yan yung pinapahanap natin. And then RBIC is 500 tangent of 60 degrees. Okay, so therefore angular BC will now be equivalent to 1,200 all over 500 tangent of 60. So that is equivalent to 1.38. Okay, 1.30, sabihin natin 39 lang radians per second. So yan yung ating gagamitin na angular velocity to solve for the value of the VC. So therefore, yung VC pala natin, okay, velocity of the block at point C, will now be equivalent to angular velocity BC, then RCIC, yung position ng point C natin from its instantaneous center. So, VC will now be equivalent to 1.39 na nakuha natin kanina. Tapos, to be multiplied by 500 all over cosine of 60 degrees. So, yung VC natin will now be equivalent to 1.39 o yung sagot na lang times 500 all over cosine of 60 degrees. Make sure na naka-degree mode kayo. So that would give us 1.1385, no? Or 1.386 na lang. 1.1386 no? mm per second. Kung gagawin natin to in meters, so that is about 1.386 meters per second. So in terms of meters class. So, yung sagot natin dito would be equivalent to this one. Okay, that would be our answer. Okay, yan lang matanong. Determine the velocity of slider block C. Yan yung tanong. So, yung sagot natin would be this one, 1.386. Okay? And then, ano pa? Proceed tayo dito sa next problem natin. Okay, next problem. Starting at 3 radians per second, when theta is equal to 0, S is equivalent to 0. So, yung dito na part, no? 3 radians per second yun. Okay, pulley A is given an angular acceleration of 0. Itong pulley A, itong part na to, is 0.6 theta radians per second squared, where theta is in radians. Determine the speed of the block P. Ito, when it has risen 0.5 meters from its initial position na nandito. Initially, yung block natin nandito yan ha. So, S is equivalent to 0. So, it has risen now to 0.5 meter. The pulley has an inner hub. Itong hub na to, okay, which is equivalent to 75 mm. Itong pulley C is 150 mm and yung pulley A is 550 mm. So, yan yung mga radius nila or radii, which is fixed at to C and turns with it. Now, so anong gagawin natin to solve for the velocity nitong block B? Actually, we can just simply use for this problem, we can simply use the rotation about the fixed axis na topic. Okay? So, how to solve for this one? Una is we need to determine the determine muna natin yung angular velocity nitong C. Kasi to solve for BB, okay, to solve for BB, that is basically yung angular velocity nitong C natin. Okay, class, yung angular velocity ng C at saka D, equivalent lang yan ha. So, angular velocity ng C times itong itong 75 mm, 0.75. 0.075. So, gawin natin in terms of meter. Okay. So, we need to solve for the angular velocity nitong C. Pero yung given natin is ito, 3 radians per second. Yan yung angular velocity nitong A natin. Now, to solve for the angular velocity ng C natin, take note that the pitch line velocity nitong A natin should be equivalent to the velocity nitong C. Okay? So, velocity ng A, which is yung etong starting at rest, hindi natin yan gagamitin because that is the initial, ha. Okay. Kasi we are to consider S is equivalent to 0.5. Pero gagamitin natin tong value nito, no, later. Okay. So, yung VA is equivalent to angular velocity ng A. Ito final, that refers to final. Tapos, yung radius ng A natin, pulley A, that is equivalent to angular velocity ng C, and then the radius ng C. Yan yung gagamitin natin na formula. Now, to solve for the angular velocity ng A, no, final, so gagamitin natin yung relationship ng angular acceleration is equivalent to the first derivative of your angular velocity with respect to time. Okay, yan gagamitin natin. O, diba, meron din tayong angular velocity is equivalent to the first derivative of theta with respect to time. So, kung yung theta natin is equate natin, no, they will, that would be equivalent to angular velocity ng, the first derivative or d omega over angular acceleration would be equivalent to d theta over angular velocity. So, therefore, yung angular acceleration to be multiplied by d theta is equivalent to omega d omega. Okay, yan yung ating relationship, no, na nakuha natin. Because we equate dt equivalent to dt in here, ha. Okay, so ito yung makukuha natin na relationship, no. So, gagamitin natin to solve for the omega a. Okay? Now, taking the integral of this one, so ano yung angular velocity natin? Angular velocity, angular acceleration para is given to be 0.6 theta. So, 0.6 theta. So, we have here d theta equivalent to our unknown, okay, omega. And that is evaluated from t, ito yung gagamitin natin na limits. 3 initially, no, to 0, to w. Yan yung hinahanap natin, wa. Okay? So, 3 to WA, no? Or later, pwede natin gawin. Later natin yan gagamitin. Okay? Tapos, DW. Okay? So, kunin natin tong integral nito. So, 0.6 integral of this one will be equivalent to theta square over 2 evaluated from later na lang plus C. Okay, gawin natin plus C. Ito, omega squared over 2. And then, yes, that's it. Now, gagawin natin ngayon is to simplify this one. 0.6 divided 2 would be 0.3 omega square, theta square plus C equivalent to, okay, 1/2 of omega square. So, evaluate natin to. At sabi dito, at theta is equivalent to 0. Yung S natin is equivalent to 0. And that would give us a starting angular velocity of equivalent to 3. So, kukunin natin yung value ng C. So, theta equivalent to 0. So, itong part na to will be just equivalent to 0 plus C is equivalent to 1/2. Then, omega natin is 3 square. So, yung sagot dito would be 9 over 2 or that is simply 4.5. So, yung C natin would be equivalent to 4.5. So, from there, that is 0.3 omega theta square plus 4.5 equivalent to 1/2 omega square. So, gagawin natin is to solve for the value of omega. Solve natin yung value ng omega. Okay? At the instant that our theta, no, is nag-move na siya by 0.5 meters. So, to solve for the value of theta, we can use the arc length, no, formula, r theta. So, paano natin yun i-solve yung r theta? Sandali, class. Since S is given na 0.5 meters, so anong gagamitin natin na R dito? Okay, gagamitin natin ng R dyan is yung R ng ating itong hub D. Okay? So, since yung S natin, itong part na to, yung block na nag-move is proportional to or associated with the hub ng D. So, itong R na to is gagamitin natin ng 0.0075 na ka-meter. So, para makuha natin yung theta natin. Okay? Theta na minove ni pulley C. Okay? Similar lang siya sa pulley D. So, si theta C is equivalent lang sa theta D, ha? Okay? So, this one will be equivalent to, theta C will be equivalent to, okay, 0.5 divided by 0.075. So, you would get 6.67. 6.667. And that is naka-region. Okay? So, yan yung omega C natin, no? Sorry, class. Now, if we will, pero yung gagamitin natin, no, dito na omega is omega A, ha? To relate omega C and omega A, we can simply use the relationship of omega C and omega A such that yung S natin sa na minove ng ating belt, no, is equivalent sa S ng minove ng ating block. So, itong part na to sa A, itong part na to sa block D. So, dito gagamitan natin yan ng omega angle A or theta A tapos radius ng A equivalent to theta C tapos radius ng C. Okay. Or simply yung theta C or yung radius ng D. Okay, yung block natin. So, ano ba yung block natin? Naka-D, Okay, D yan. So, itong part na to is yung distance ng B, ha, na move. Similar lang siya dito. Makukuha natin yan. So, kukunin natin yung angle theta A. So, yung radius ng A is 50 meters. 50 mm, sorry. 50 mm. So, that is 0.05. 0.05 equivalent to, yung nakuha natin, 6.667. Tapos, RD. Okay. No. RC pala yung gagamitin natin dito kasi angle theta C tayo dito. So, kasi yung pulley A tsaka pulley C, sila yung nakakonect dito sa belt. Okay? Nakuha nyo? Pero, similar lang yung angular position na nabo dito or angular displacement nito, ha, kasi they are just connecting or they are lying on the same shaft. So, dito, gagamitan natin yan ng RC. Yung RC natin is equivalent to, radius ng C is 150 mm or that is 0.15. So, therefore, yung makakuha natin na angle theta or theta A will be equivalent to, okay, multiply natin to by 0.15. 0.15 divide natin by 0.05. You would get 20. So, yung angle theta natin or theta A is 20 radians. So, yan yung gagamitin natin dito na equation. Okay, dito ko na lang to ilagay, class, ha. Okay, move ko na to dito. So, to solve for the omega A pala, sorry. So, this is 0.3 tapos 20 radians square plus 4.5, no? Equivalent to 1/2 tapos omega A squared. Okay? Omega A squared. So, to solve natin yung omega A squared. So, plug in natin sa calculator. 0.3 times 20 square plus 4.5 equals to 0.5 or 1/2 tapos x square. Shift solve. Let's assume a value of 10. So, we'd get 15.78. So, omega A would be 15.78 radians per second. Yan yung omega A natin. Which is yan yung gagamitin natin to solve for etong class. Determine the speed of the block B. So, kung solve natin yan, gagamitin natin yung omega A natin to solve for the omega C. Then, yung omega C is just equivalent to omega D, ha? Omega C is equivalent to omega D. Then, masasolve na natin yung velocity ng block which is equivalent to omega C or omega D times 75. Yan na yung magiging final natin na process. Okay? From here, okay, ito yung pinapahanap natin, ha? So, gagamitin natin to solve for this one. Okay? Okay, from here, so since nakuha na natin yung omega A natin, so yung omega A natin is 15.78, okay? So 15.78, yung R natin ng A is 0.05 or 50 mm, equivalent to omega C, yung pinapanap natin dito na part, then RC would be 0.15. So, omega c will now be equivalent to 15.78 tapos 0.05 all over 0.15. And that would be equivalent to 5.26. 5.26 radians per second. So, yan yung gagamitin natin dito to solve for the value of velocity nitong block B. Okay, tapos 0.075. So, masasolve natin dito, multiply lang natin ito by 0.75. So, you would get 0.394 or 395. 0.395 meters per second. So, yan na yung ating velocity ng block T. Okay, so to wrap this up, no? So, ang ginawa natin, class, yung starting at 3 radians per second, yan yung initial velocity nitong omega A, itong pulley A. Pero hindi yan yung gagamitin natin omega A, ha? Kasi that is the starting or initial condition when theta is 0 and s is equivalent to 0. Now, yung pulley A doon natin is given an angular acceleration of 0.6 theta. So, since meron tayong angular acceleration, meaning to say, yung kukunin natin na angular velocity here would be the final angular velocity. Pero gagamitin natin tong 3 radians per second later for our initial value problem. Okay? So, ginamit natin is yung relation nito. Okay, relation na ito, class. No? So, kinuha natin yung equation ng ating omega na final. Okay? So, in-integrate natin yan. So, nakuha natin tong part na to. Then, ginamit natin yung condition that at theta is equal to 0, s is equal to 0, then omega is 3 radians per second. Therefore, nakuha natin ng value ng c, which is 4.5. And then, that would make our final equation to be like this one. No? But, there is also a problem kasi wala tayong omega, theta a pala. So, saan natin yung kinuha? Dito. Since yung s natin is already given, which is 0.5, associated yan with this part here, kana itong hub D. So, kaya ginamit natin dito is yung radius ng hub D para makuha natin yung theta C. Take note, yung theta D at saka theta C, equal lang yan siya. Kasi, they are installed on the same shaft. Okay? So, kaya yung theta C dito is 6.667. And then, since yung pulley A natin and pulley C are on the same belt lang, okay, therefore, whatever yung magiging linear displacement ng pulley A at saka linear displacement ng C class, okay, C to class equivalent lang. So, kaya theta A, RA equivalent to theta C, RC. Okay? So, therefore, ginamit lang natin yung radius ng A, which is equivalent to 0.05 or 50 mm, since to solve for the value of theta A. And then, yung theta C, nakuha na natin to be 6.67. And then, yung radius ng pulley C, which is 0.15. So, nakuha na natin yung theta to be 20 radians. Then, we plug in it here to solve for the omega A. Then, nakuha natin yung omega A. Balik tayo dito sa ating initial working function. So, 15.78. So, nakuha natin yung omega C. And finally, ginamit natin yung omega C to solve for the value of the velocity at the block B. So, yan yung magiging process natin for this problem. So, I hope nakuha nyo, no? Now, for our next problem. So, ito. At an instant, the horizontal position of the weather balloon shown is defined by x is equivalent to 10t feet, where t is in second. If the equation of the path is y equivalent to 3x squared over 5, determine the magnitude of the velocity and acceleration when t is equivalent to 2 seconds. Sandali lang. Check ko lang kung nagre-record pa ba. Okay. So, in this problem, this is part of a curvilinear, no? Curvilinear motion. Since yung ating object na weather balloon is moving in a seemingly curved path, no? Wherein meron siyang, yung x natin is changing with time, which is 10t. And then yung y natin is also changing with the position, which is 3x squared over 5. Changing with position siya, no? Now, to solve for the magnitude of velocity, recall that velocity here is equivalent to square root of velocity x plus square root of velocity y. Okay, sorry. Velocity x squared plus velocity y squared and square root of that. Then for acceleration, similar lang din. Acceleration x squared plus acceleration y squared and square root of that. Now, kunin muna natin yung velocity x. Recall natin that the velocity x is the first derivative of x with respect to time. Then velocity y is the first derivative of y with respect to time also. And then if kukunin natin yung ax natin, acceleration along x, so kukunin natin yung velocity ng derivative ng velocity x with respect to time, no? And similarly, kukunin natin yung acceleration of y, that is the first derivative of the velocity along y with respect to time. So yan yung gagamitin natin ng mga equations. Okay? Now to solve for vx, kunin natin yung vx. So that is just the first derivative of x with respect to time, which is obviously equivalent to 10. No? Kasi derivative ng t with respect to t is dt over dt, or that is simply 1. So yung velocity along x will be equivalent to 10. So that means yung acceleration natin would be 0 kasi the derivative of 10 is just equivalent to 0. Now for velocity of y, so first we need to determine itong part na to, we will be deriving this one with respect to what? So derive natin ito with respect to time. So this one would be y plus, this is 3x squared over 5. Okay? So sorry, this is y equivalent to 3x squared over 5. So, derive natin to class ha. So yung vy natin would be equivalent to derivative ng y with respect to t, that is dy over dt, which is equivalent lang to this vy. So derivative nito, 3/5. Natin yung factor out. The derivative ng 2x would be 2x. Derivative ng x squared would be 2x. Then derivative of x with respect to t, that is dx over dt. Dx over dt. Or simply, this one is equivalent to vx. So, itong part na to is vx lang, or v sub x. Okay? Ayan na yung ating magiging equation for velocity ng y. So, simplify lang natin, which is 6 over 5 x vx. Okay? And then ito na yung ating vy, no? So plug in lang natin yung mga values na meron tayo. 6 over 5, yung x natin is 16 feet. And yung vx natin na nakuha kanina is 10. Okay? So yung sagot dito would be equivalent to 6 over 5 tapos 16 times 10. Okay? Yung sagot dyan is 192. Okay, 192. Then that is feet per second. Okay? Ito pala class is feet per second din to. Now for our acceleration, okay? Acceleration at y. So kukunin natin yung derivative ng vy natin with respect to time, no? So ano na yung derivative ng ating itong vy natin, ito yun, no? 6 over 5 x vx. So since yung x at saka vx, v sub x is both changing or differentiable, so differentiate natin yan. Una, we can factor out 6 over 5. Derivative ng x is dx over dt. Then, copy natin yung vx. Bale, we are using a product rule here. udv plus vdu. Plus, copy natin yung x. Derivative ng vx is equivalent to acceleration x. Or that is simply dvx over dt. With respect to time tayo class ha. So, yung a sub y natin would be equivalent to 6 over 5. Yung dx over dt, similar lang yan sa vx, no? So, therefore, we have here vx square. Or yung vx natin is 10. So, basically, this is 10 square. Plus, yung x natin is 16. Yung dvx natin over dt, that is equivalent to our acceleration, di ba? This is dvx over dt, which is equivalent to 0. Kaya, 0 ito plus. Ito, magiging 0 lang yan. So, for our acceleration along y, that is basically equivalent to 6 over 5. That is to be multiplied by 10 squared. Okay, yung sagot dito is 120. 120 feet per second squared. So, buo na yung magiging natin, no? Mga values natin for a, y, ito yon. For ax naman, ito yon, which is 0 lang. Okay. Then for vx, ito yon. And then for vy, ito naman yun. So, masosolve na natin yung vx natin at saka yung v natin at saka yung a natin. So, kunin ko lang to ulit. Saglit, class. Dito na natin lagay sa first, dito sa ibaba. So, yung v natin pala, equivalent to vx natin is 10 square plus yung Vy natin, nakuha na natin, which is 192. Okay, 192 square. So, anong sagot natin dito would be equivalent to 10 square plus 192 square. So, that would give us 192.26. So, velocity natin is 192.26. So, that is feet per second. So, yan yung sagot natin for this problem. For velocity lang ha. Okay. Now, for the velocity, for the acceleration, no? So, yung acceleration x natin is 0 squared. Acceleration y is 120 squared. So, therefore, yung acceleration natin is 120 feet per second squared. So, yan naman yung sagot natin for the acceleration. Okay. So, yan na yung sagot natin for this third problem. So, ilang problem na ba na-solve natin? Tatlo. And then, last na to, no? Okay. For the last problem, a smooth 2 kg collar shown is attached to a spring having a stiffness of, itong stiffness daw nito is 5 Newton per meter. And then, yung stretch natin is 0.75. So, yung y daw natin, itong y na to, is, okay, which is equivalent to this one, is 2 meters lang. Sorry. 2 meters daw to. And then, yung collar natin is 2 kilograms. Okay. Now, ang tanong dito is to solve for the acceleration na naka-meter per second squared at that instant that yung y daw natin is 2 meters. So, pwede natin gawin is we can use the conservation of energy. Mas madali ito, class, no? If we will be using conservation of energy. So, there are plenty of ways to solve for this one, no? Pwede natin gamitan ng impulse, pwede natin gamitan ng mass acceleration method, pwede natin yung conservation of energy. But among those three, I would prefer to use conservation of energy for here. Pwede naman din isolve yan using summation of forces along x equivalent to mass acceleration x, and then summation of forces along y, mass acceleration y. Ito yung sinasabi ko na mass acceleration method. Mass then acceleration method. Okay? Pero again, ang gagamitan natin na equation for this problem is itong conservation of energy. Okay? So, sa conservation of energy, pinakaunang gawin is create a reference line. So, ang ginagawa pag ganitong setup, yung reference line is yung initial position ng ating ating collar. So, initially daw, yung collar natin is nasa position ng A. So, that is, theta is 0 pa. So, nagbaba naman yung collar natin, so expect that, okay, yung yung conservation of energy pala natin na formula is kinetic energy at state 1 plus potential energy at state 1 equivalent to kinetic energy at state 2 plus potential energy at state 2. Or, in other words, ito yung A, ito naman yung position ng C. Okay? So, initially, yung A natin is 0, kaya yung velocity natin dito sa A is 0. So, 0 din itong kinetic energy. Since ginawa natin itong reference line na itong point A, so this one is also 0. So, meaning to say, itong left-hand side na equation will be equivalent to 0. So, itong right-hand side, meron tayong value dyan. Meron tayong 1/2 mass ng collar, tapos velocity ng collar square. Plus, okay, take note, meron tayong binaba na elevation. So, meaning to say, bumaba naman yung potential energy natin. Since nagbaba yung potential energy natin, pero naka-attach sa spring, meaning to say, initially, ito yung potential energy ng spring. Wala pa. Pero since nag-stretch siya, meaning to say, nag-increase yung potential energy ng spring. So, itong potential energy dito, at point C, is the summation ng potential energy ng spring na tinaas at yung binaba na potential energy ng ating collar. Okay? Due to its decrease in elevation. So, meaning to say, okay, itong part na to sa potential energy at point C is equivalent to 1/2 tapos K ng spring natin, then yung stretch na na-stretch na length ng ating spring square, no? That is to be subtracted by the decrease. Ito yung increase ng potential energy ng spring. that is to be subtracted by the decrease in potential energy of the collar kasi bumaba yung elevation niya. So that is mass of the collar, then gravity, tapos yung binaba na height, or simply yung y. Okay? So yan yung magiging equation natin na. So pwede natin gawin is to rearrange this one. Unahin lang natin to and then equate that to 0. So, similar lang yan, class. So now una natin gagawin is to solve, since ang gagawin natin dito is to solve for VC, okay? So solve natin yung VC natin and then later makukuha na natin yung AC natin, no? But to solve for VC, since itong K already given, yung S natin hindi pa yan. Yung Y already given na. G, of course, that's constant. So yung S lang yung problem natin dito. So paano natin kukunin yung stretch, length na stretch? Itong length na to. So di ba yung unstretched length is 0.75. So kukunin natin tong length na to, then isa-subtract natin yan dyan, galing sa 0.75 na unstretched length, makukuha na natin yung stretch length. So to solve for S, no, that is basically stretch length. Okay, yung final length pala, yung final length ng ating spring dito minus the unstretched length, which is equivalent to 0.75 meters. So, kunin natin yung final length natin. Paano natin kukunin yan? Okay, basically naka-create tayo dito ng parang right triangle. So 0.75 ito 2 meters, makukuha natin yung hypotenuse, which is yung final length. So solve na natin, i-redraw na natin saglit. So this one is our final length, sabihin natin FL. Ito naman yung 2 meters, ito naman yung 0.75 meters. So gamitin na natin yan ng Pythagorean theorem. So 2 square plus 0.75 square. So yung final length natin would be equivalent to square root of 2 square plus square 0.75 square. So yung sagot dito is 2.136. So dito na lang tayo. 2.136 meter. So yung S pala natin would be 2.136 meters minus 0.75, and you would get 2.136 minus 0.75. Makukuha nating value dito is 1.386. 1.386 meters. So yan yung gagamitin natin na S value. So yan yung gagamitin natin na S value. Okay? So galing dito, okay, galing dyan. So 1/2, yung mass ng collar is 2. Tama ba? Mass ng collar is 2 kilograms. Yes. VC, yung hinahanap natin, square, plus 1/2. Yung K natin is 5, based on the given, 5 Newton meter. Then yung S natin is yung na-stretch, 1.386 square. Okay, minus yung mass ng collar, 2, tapos 9.81, constant gravity. Then Y would be 2, equivalent to 0. So shift solve, makukuha natin yung value ng C natin. Okay, sige. That is 1/2 over 1/2 times 2, which is equivalent to 1 lang yan. So x squared na lang lagay natin. Plus 1/2 times 5 times 1.386 square minus 2 tapos 9.81 tapos 2. Okay, shift sorry. Mali. Alpha equals to 0. So shift solve. Let's say for example 5, makukuha natin yung velocity C, which is 5.87 naka-meters per second. Yan yung velocity natin sa ng collar at point C. Pero ang tanong dito, determine its acceleration. So paano natin i-relate yung velocity C sa acceleration C? Okay, using what? Rectilinear motion lang, no? Free falling. So for acceleration, since initially 0 siya, so VC equivalent to initial velocity ng ating collar at point A plus acceleration at C. Tapos yung time, no? Supposedly kung gagamitin natin to. Pero since ni yung given ng time, yung Y yung given, pwede natin gamitin is velocity C square plus velocity ng A square, initial velocity ng collar natin, plus 2 acceleration at point C, then yung binababa, Y. So since this one is just simply equivalent to 0, so this one is 5.87, no? 5.87 squared equivalent to 0 plus 2. AC yung hinahanap natin, and yung Y natin equivalent to 2. So that is basically 5.87 square, divide natin by 2 times 2, magiging 4 yan. So yung AC natin would be equivalent to 8.61. So 8.61 meter per second squared, or MPS square. So yan yung sagot natin for this problem. Okay? So I hope nakuha nyo yan, no? That's it for this video. I hope that you were able to follow the solution, and I see you in the next one. Thank you everyone for attending.